Okay, thank you. Okay, now can you see this? Okay.
Yes, Doctor.
Yeah.
Okay, now this is what I'm talking to you just now. This is the cumulative binomial probabilities for probability of success 0.01 until 0.09. Where here you can see 0.01 until 0.09. Okay, what do we mean by cumulative? Because the sign here is less than or equal to. How do I know? Okay, what is n, class? From our previous discussion, what is n? What is n? Number of
Number of success.
number of trial. N is the number of trials. Number of trials. Okay. What is x? X here is your representation of your number of success. Number of success of your binomial experiment. How many success? X number of success. Now, if let's say number of trial, I'm talking about one number of trial. It's either you get 0 success or 1 success, correct? 0 success or 1 success. That's why in cumulative binomial probabilities, they will provide you each and every cumulative probabilities from 0 success until the nth success. Okay, let's say I'm talking about 2 trials. You may have 0 success. That's why you have 0 success, 1 success, 2 success. Yeah. If you got 3 trials, you got 0 success, 1 success, 2 success, at most 3 success. Correct? So, let's say we are talking about 10 trials. You can say from 0 success until 10th. But now in this case, it stopped until 6. Why? Because everything give already 1. Everything got 1. Should be followed by 7, 8, 9. I don't know what happened today, okay? Still need holiday maybe. Suddenly my computer turned off, okay? So I'll need to begin again. Let me open my document first. Okay, can you hear me, class?
Yes,
Can.
Doctor.
Okay, sorry, my laptop suddenly turned off on its own. Okay, I think I'll just use my PDF since the PDF seems to be okay to be written on. Okay, let me open my PDF. Okay, I think this should be okay. Okay, now I need to share the screen. Okay, can you see my PDF here now? Class?
Yes, ada.
Okay, now class, when I see just now, you got 4 trial. Okay, when you got 4 trial, okay, you will stop at 4 successes. But somehow, there will be times where you got, for example, in this case, you got 10 trials, but you stop at 6 successes only. Can you understand what I'm saying here, class? You got 10 trials, should be 10 successes, right? But now you only get 6 successes at maximum, right? Can you see class here? Yeah. So why does it stop at 6? Can someone tell me why?
Because 6 is all 1, 7 will be all 1, 8
Yeah,
will be all 1.
because the probability for 6 successes already give you exact what we call uh will occur, okay, exactly 1 probability value. So that's why it will stop at 6, means that at 7 successes, at 8 successes, 9 and 10 successes, all of the probability values are 1, the same as number 6. Okay, that's why we stop at 6 successes only. Okay, the same goes to number 11 here. 6 successes only. If I'm not mistaken, 6 successes only. Yes. Okay, so please understand how to look and to refer to your binomial table. Now, this is only the first page. What if I have, okay, so we are talking about from 0.01 success until 0.09. You can have up until 45, 100 trial. 100 trial for probability of success as small as 0.01 and maximum 0.09. Can we have other than 0.01 successes? Yes. For example, we can have this one. We have 0.1 success probability value. We have 0.5. Okay? Okay, 0.1 until 0.5. And we begin again with 1 trial, 2 trials, and up until 100 trials. Oh, in this case, only 30 trials. Just now, up 100 trial. But for 0.5 maximum, it only give you until 30 trials. But for 30 trials, look at the given successes. 0 success, 1 sorry class, it happened again. Suddenly my laptop got restart. Okay. Not sure why. I think maybe because I'm using the PDF and it should be, the laser should be out. But somehow using PDF, my pen is okay. Okay, never mind. I'll just share the screen. Okay, can you see my slide here? Okay, now class, if you can see, if you can check from your any text, from what we have in our textbook, I believe the same goes to any binomial table. The maximum probability of success given in your table of success of binomial will be maximum of 0.5. Okay, there will be no more than 0.5 probability of success. Okay, and if you look afterwards, you will get the Poisson probabilities, means that you will stop at 0.5 for probability of success for binomial, and the number of trial will be up until 30 only. Okay, so that will be some of the variation in the binomial table. Do you have any question, class, so far? If you don't have any question, I would like to explain how this become a cumulative binomial. Okay, let us find the page with the formula here. For example, this one. Now, we know that this is by cumulative binomial probabilities because we are talking about probability of success less than or equal to k. K is any success values. Okay, for example, I took number two trials. Okay, the first, if I'm talking about if let's say in this case for this one, okay, for 0.10, x is binomially distributed with number of trial 2 and probability of success is 0.10. Okay, so in this case, when we say px equal to 0, so this is what it gives. Okay, so px equal to 0 is 0.8100. Okay, now when I say this, this is we say as px less than or equal to 1, which is px equal to 0 plus px equal to 1, which is 0.9900. Okay, so this is what it meant by cumulative probability distribution. So if you are talking about the third successes, you got 2 trials and both are success. Okay, so means that you have px less than or equal to 2, which means that you have zero success, 0 success plus 1 success plus 2 success. Okay, you get 1. Okay, so that's how we read the cumulative probability distribution for binomial. Anyone got any questions so far, class? Anyone, any question?
Betul.
Yes.
Usually we need to do this table?
You are going to need this table because you are not going to be asked to find the probability of x equal to 2. You may not be asked this all the time. You may be asked about finding your x greater than 2. You can be asked finding the x greater than 1 but less than or equal to 5. So all these require table. All these require table, but this one you can use your formula NCX p to the power of x q to the power of n minus x. For this particular case, you can use the formula. You can use the formula. For example, if you are talking about px greater than 2, let's say your experiment is binomial with 10 trials with probability of success is 0.1. How are you going to find x greater than 2? We know that px greater than 2 is actually px equal to 3 plus px equal to 4 plus px equal to 5 until I'm really sorry. It happened again. I think the PDF element does not allow me to use the pen because it's supposed to be problem with using the pen. But it seems to be okay by using the... Okay. I repeat again, why do you need your table in order for you to... Let us use this, okay? Hopefully everything will be okay afterwards. Okay, so let's say you have now it's okay. Hopefully will not restart suddenly. Okay, if let's say X
Sorry.
you have okay, I forgot to share the slide, right?
Yeah.
Okay,
Yeah.
sorry. Thank you. Okay, now Alhamdulillah, I'm using my Note 1 right now. It seems to be okay. Hopefully it will not restart suddenly. Okay. Okay, let's say I repeat again, X of distributed with binomial with number of trial 10 and probability of success is 0.1. Now you are looking for Px greater than 2. You can use your formula, I know. You can use your formula, but the way you use, you will have to work a lot. Because in order to find X greater than 2, because the number of trial is 10, we know that the number of successes will be Px equal to 3 plus Px equal to 4 plus until 10 successes, right? Px is equal to 10. And you need to use the formula for each and every what we call success here. So you will have to repeat S. So you will have 10C3, 0.13, 0.97 plus 10C4, 0.14, 0.96 plus until the 10th, 10C10, 0.110, 0.90. So are you going to calculate all this? It will require more time. Okay, if you use your table, everything will be simplified for you. And we know that by using table, we know how to find. It will be Px greater than 2 is just 1 minus Px less than or equal to 2. And we can use from our table, okay, 1 minus less than or equal to 2 for this particular table. You can find what it is and you can find the probability value. As simple as that. 2 steps only. But if you are using your formula, it will require a lot of processes. Can you understand why we need that table, class?
Yes, doctor, I
Okay.
understand. But the table is given, or do we need to create the table?
Oh no. The table will be always be given to you. Okay,
Oh,
but for your exercises, for your answering the examples, the exercises and everything, the tutorial, you need to find binomial table. It's either you use my table that I will provide you afterwards, or you can use any binomial table available in the Google search. Okay, you can use any binomial table. Everything will be the same because it will always cumulative binomial probabilities. Okay, so let us move to our first example for cumulative binomial probability distribution, how we can use table in order to help us out with the answering the questions. Now, in a binomial distribution where the number of trials is 12 and the probability of success is 0.3, find the following probabilities. Okay, so first write down your probability, your distribution of your X. Okay, so X in this case is the number of success of anything. We don't know because it does not mention here. So we can write down X is distributed with binomial with number of trial 12 and probability of success is 0.3. If this is an open-ended questions, this one usually will give you 1 mark. 1 mark. Okay. Then finding probability x less than 5. Okay. The first one is finding px less than 5 means that we have from 0 success 1, 2, 3, 4, 5 up until 12, right? So we need to find less than 5. 5 is not included means that it will be from 0 until 4. So this is reflecting px less than or equal to 4. Okay, that will be your first step in order to answer the first questions. At this stage, do you have any questions? Do you have any question here, class? Why I need to transform to this? Because remember class, this is a cumulative. The cumulative table just now says what? Px less than or equal to k, blah, blah, blah. So we are trying to come up with this notation so that we can use directly our table, binomial table. Okay, that's why we transform less than become less than or equal to what? Less than 5 is less than or equal to 4. Then from this, we can use our table. Look for N12. Look for P 0.3. And we are talking about less than or equal to 4. So directly your answer is 0.7237. Okay, so if we transform this into percentages, this will be 72%. 72% of what? 72% chance that this less than 5 successes will occur. 72% of less than 5 successes will occur. Okay, so that will be A. What about B? Px less than or equal to 5. Can someone give me the answer?
Zero point 8822.
Yes, correct. Directly from your table. What about C? Px greater than or equal to 9. We are talking about 5, 6, 7, 8, 9, 10, 11. Now we are talking about 9 and above. So means that 9 is also included. So this will be what? 1 minus what? Go back to your formula again. Formula number 4. Okay. Since 9 is included, means that we have to deduct 1 because 9 is included. So it will begin from 1 minus px less than or equal to 8. Okay. So this become 1 minus px less than or equal to 8. So 1 minus what? 1 minus 0.9983. So what do you get here?
0.1127.
0.0017. Is it correct? Okay. What about D? This one is a bit challenging because you need to understand what is before, what is after. Greater than 5, but 5 is not included. Less than 9, but 9 is included. 5 is not included. So means that you begin from 4 until 9. So this is where Okay, so this is what you are looking for. What will be the probability value? So if you look at your formula just now, okay, look for greater than, less than or equal to. Okay, so if we apply that rule, we can have P x 5 9. This will be P x less than or equal to 9 minus P x less than or equal to 5. Okay, so this will be what? Equal, less than or equal to 9 is 0.9998 minus less than or equal to 5 is 0.8822. Okay, so what is the answer? Okay, so the first part here, less than or equal to 9, less than or equal to 9 exactly, and then greater than x1, it become this one. So that's why we have this one. Okay, what is the value here, class?
0.1176.
0.1176. Is it correct? 99. Okay. Okay. What about number E? E P X 3 5. So in this case, if we apply the rule, okay, it will be 5 minus P x less than or equal to 5 minus P x less than or equal to 2. Okay, 5 and 2. So this will be 0.8822 minus 2, 0.2528. What's the value here?
Zero point 6294.
Okay, 6294. Okay, correct. Okay, so that's how we find what will be the probability given any binomial, given binomial probability distribution with number of trial 12 and probability of success 0.3. Any questions so far, class?
Actually, doctor, for number D, I still couldn't get it how we.
Okay. Okay. Because it is a combination of two, less than or equal to and greater than. So look for each terms here. Okay. The first term is x is less than or equal to 9. Then go back to your rule. Less than or equal to 9 is this one. So it reflects this one. Okay. Because it's the upper value. Okay. The first part, that will be x less than or equal to 9. The second part is x is greater than 5. If I change the highlight, greater than 5 is this one. Greater than. Then look for greater than rule. Greater than rule is this one. So this one, is this part. You are using the same value, x1. Okay, so that's why it become this one. Okay, it become this one. Okay, so since this is your first exercise example, so it will be a bit confusing. It's okay. Okay, later on you will see in your example and as well as tutorial questions. Okay, any other question for this example?
Dr.
Doctor,
Yeah.
for the same question,
Mm-hmm.
the the x is greater than 5, so it's supposed to start at 6, right? Instead of 4. What?
Supposed to be that way. But since we are following the rule here, okay,
Oh,
you see, because this is the lower bound and this is the upper bound, so you are looking in between. Okay, as far as I'm concerned, this is how we use the rules here, and how we can expand the rule based on the sign given is either greater than or less than, or greater than or equal to, or less than or equal to. Okay, so far as far as I'm concerned, this is how it can be done. If later I found it not correct, I will let you know. Okay, but as far as I'm concerned, this is the way we follow the rule for the cumulative probability distribution. Okay. Okay, any other question?
Doctor, those rules need to be memorized or they will be given?
Usually you need to memorize them. It's okay. It's no need to memorize, but you can have. Maybe this will be a kind of helpful for you to understand how that particular rule can be used. Okay. Um, Somehow later after the class, please go again one by one. Okay. Put some value in your rules here so that you can see how this rule can be applied if you have certain values. Okay, but I do agree with your friend's comment just now for this particular part. Okay, we know that we are, but since we are talking about discrete value, okay, so that's how sometimes you feel that is this is kind of wrong, but it's actually following the rule is the easiest way on how to do it. Okay, so if let's say you are talking about from uh 4, 5, 6, 7, 8, 9, from 9 is included, but greater than 6, greater than 5 is 6, so you are talking about this particular region. Okay, it's actually 9 is over here. This is 9. This is 8. This is 7. This is 6 actually. Okay, but not including 5. So since you are talking about from 9, from 6 to 9, okay, but since you are using the rules, that's why we start using 5 for the lower boundary. Okay, if let's say you can prove me that I'm wrong here, please let me know. I will correct my understanding. But as far as I'm concerned, this is correct. Okay, any other question? Any other question? Okay, if you got no question, so there is a rule to solve the problem of solving questions. Okay, so what would be the expected solution that you need to show whenever you answering the question regarding the binomial probability distribution? So how do you start? Usually you will start with stating what is x. What is x? Depending on your question. Then state what is the distribution of your x. Okay, what is the distribution of your x? So in this case, this is the example of what is x. What is the distribution of your x here? it reflects what is the number of trial, what is the probability of success. Number 3, state them into your binomial probability distribution. So this is what we call by binomial probability distribution. And then calculate what is given in your question. Okay. Commonly, this will give you 1 mark, and this will give you another 1 mark. Okay, 1 mark for defining what is X, another 1 mark for what is X distribution according to the number of trial and the probability of success. Now, let us try this. Can you try this? I'll begin the first 2 steps. Okay, what is X? X in this case is the number of success. In this case, the number of success is unusable for building cabinet. Okay. Board. Unusable board for building cabinets. Unusable is what we call as the success. Okay. So in this case, the number of success is the X is equal to number of unusable boards for building cabinet. Okay, so this is your definition of X. Now, according to your questions, the unusable probability is 0.10. That will be the probability of success. And what is the number of trial? Look throughout your questions. The cabinet manufacturer bought 11 boards. What is the probability that blah, 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 blah. So, 11 board is considered as the number of trial. So, in this case, P is 0.10. N is equal to 11. So, you can write down the probability of your binomial distribution. That will be 11, 0.10. Okay, 1 mark, 1 mark. Then, start answering your question. Can you try number 1 Roman class? 4 or more of the 11 boards are unusable for building cabinets. I give you already the table here. Okay. 1 minute, in 1 minute, please. So 1 Roman will be Px greater than or equal to 4. Number 2 Roman, at most 2 of the 11 boards are unusable. At most 2. So Px less than or equal to 2. Okay. 3. None of the 11 boards are unusable. So in this case, Px is equal to 0. Okay. Now, number 2 is easy. What about number 4? You are talking about 3, 4, 5. 4 and above, 4 included. So the whole total probability is 1. Knowing that looking for greater than, we can use 1 minus P x less than or equal to what class?
3.
What?
3.
3. Correct.
3.
So 1 minus Px less than or equal to 3 for 0.1 and 3. So 1 minus 0.9815. So you get what class?
0.0185.
Yes, okay, right. What about number 2, Roman? Directly from your table, px less than or equal to 2? At most 2.
0.9104.
Yes. Okay, high likely. This is less likely. What about exactly 0? What is the probability value?
0.3138.
Yes, correct. Okay, so that's how we solve what we call the binomial probability distribution problem. So most of the time, you will be given this. Okay, you are not going to be provided with what is the probability distribution, what is x referred to. So everything will be in terms of, unless you are given what we call multiple choice questions or true or false questions, then everything will be simplified as it is. But if it is what we call open-ended questions, everything will be given in terms of these particular questions. Okay, so I hope everyone can know how to develop what is defined as x, what is the distribution, and start answering the questions. So class, I think we have out of time. It's already 10:35. So I'm really sorry for today's class. So many distraction. Hopefully, with the video later on, we'll just edit everything so that everything can be clear and simplified for you. Okay, thank you very much for today's class, and don't forget to fill in the attendance for today's class.